Okay, so the first question in homework number 3 is to calculate the interest earned by saving 9,000 for 5 years at 8% simple interest rate. Okay, now so to solve the simple interest problem, the formula you're going to use is this one, I equals to P and I. And question number 2, based on question 1, if P is the principal, I is the effective interest rate per interest period, and N is the number of interest period, what are the correct values of P, I, and N? So to use this formula, of course, you need to decide what is the values for those variables P, N, and I. So because you are the interest earned is by saving 9,000, so that's the principal. So P is 9,000, and I is the interest rate per interest period, and according to this problem, it's compounded annually, so that 8% per year will be the effective interest rate per interest period. So I is 8%, and it's compounded yearly, so the number of years will be the number of compounding periods. So it's N. So the N is 5. So the answer is P is 9,000, I is 8%, N is 5. Based on question 1, what is the interest earned at the end of the 5th year? So this is talking about the interest earned. So it's I equals to P and I. And P is 9,000, N is 5, I percent is 8%. So the answer is 3,600. That's the interest you earned. But talking about the total savings in your account, that's kind of total payback. So the total payback will be the I plus the principal, right? How much you invest and how much you earn as interest. So the I is 3,600 plus 9,000, which is 12,600. So question number 5 is a new one. It's to calculate the interest earned by saving 9,000 for 5 years at 8%. Sounds the same as the first question, right? But it's compounded annually. So it's a compounding interest problem. So compounding interest problem formula is this one. To use this formula, you first need to decide the values for those variables P and I and N. Okay, so P is still the principal, that is the amount of money you save. So it's 9,000. And I, in this problem, it's because it's compounded annually. So the 8% is still the effective interest rate. Okay, because 8% is the yearly percent and it's compounded annually, so it's the yearly interest rate will be the effective interest rate. And because it's compounded every year, so number of years will be the value of N. So it's N equals to 5. So this is the correct answer. And so now you need to calculate the interest earned. So interest earned based on the formula, it's P times 1 plus I to the power of N minus P. P is 9,000. 1 plus I is 8%. N is 5 minus 9,000 again. So the answer is 4223.95. And based on this interest, what is the total saving in your account? That means what is the total payback? So it's gonna be I plus the principal investment. So it's 4223.95 plus 9,000. And the answer is 13,223.95. Okay, now there is the new question. Calculate the interest earned by saving 9,000 for 5 years at an annual interest rate 8%. Exactly the same as the previous questions, right? But it's compounded quarterly, so every 3 months. Okay, so what formula do you use? Still, this is in a compounding interest problem, so the formula is the same. But the values for those variables are going to be different. So P, of course, is still the principal investment. It's 9,000. But what is the I? I is the effective interest rate per interest period. Okay, but in the problem statement, this annual interest rate of 8%, that's kind of nominal interest rate. It's not interest rate per period. Okay, it's interest rate per year. So you need to convert the 8% per year to some percent per interest period. In this case, it's 3 months. So per 3 months. So what is the interest rate per 3 months? It's gonna be 8% divided by 4, because every year you can compound it 4 times. So it's gonna be 2%. Okay, so I is 2%. And the N is number of interest period. It's not necessarily is the number of years, okay? It depends on how frequently you compound it. If you compound it every quarter, so it's number of quarters during the many years. So during the 5 years, how many quarters do you have? So it's, you have 5 years, right? And how many quarters do you have per year? 4 quarters. So in 5 years, you have 20 quarters, which means the N is 20. Okay, so this is your correct answer. So based on these values and the formula, what is your interest earned? Still use this formula. P is 9,000, 1 plus I is 2%, N is 20, minus 9,000. So the answer is 4373.53. And based on this, what is the total saving in your account at the end of the 5th year? So that's total payback. It's I plus P. So it's I plus 9,000, which is 13,373.53. All right, question number 13 is about the equivalent values. Okay, so Tom wants to invest his money in the market. He is interested in one stock which could yield an interest rate of 5% annually. So if Tom invests 10,000 at present, so 10,000 is a present value for 6 years, how much in total he can get back at the end of the 6th year? Okay. So to solve this problem, you first need to draw the cash flow diagram. But so from these four options, which one is the correct from Tom's perspective? Okay, so Tom's perspective is different from the stock market, right? Or from the company whose stock is bought by Tom. So because Tom needs to pay 10,000 at present, so that payment is outgoing cash flow. So it's an arrow going downward, 10,000, and no cash flow during every year. But at the end of the 6th year, Tom needs to get back the total, okay? So that's gonna be his receiving, and it's unknown, and it's a future value. So, and the I is 5%. So based on this, what is the correct answer? So it's gonna be this one. And based on the question, what formula do you use to calculate how much total Tom can get back? Because the total Tom can get back is actually the total payback, okay? It's not just the interest, it's interest plus the principal, okay? So if interest is P times 1 plus I to the power of n minus P, so P plus I is gonna be this plus I, right? So it's P 1 plus I to the power of n minus P plus P. So these two are cancelled. So the final answer is P times 1 plus I to the power of n. So this is the formula you can use. And based on this question, how much in total Tom can get back? So use that formula. Your future value is, it's not 9,000, it's 10,000 times 1 plus 5% to the power of n. So the answer is 13400.96. Based on question 13, if you use the factor method to solve this problem, what is the correct factor to use? So the factor method to use factor method, you need to determine what equivalent value you're looking for. So now you're looking at the future time. You want to know the future value of the present investment of 10,000 by Tom, right? So you're looking for future value given the present value. So it's F/P I% and N. That's the factor. And I is 5%, N is 6. Okay, so it's this one. And so you're going to check the table in Appendix C, the table of I equals to 5% to look for the factor. And that factor is gonna be this one. Question 18, it's another problem. So suppose the contribute $10 per week. So $10 per week is equal to $520 per year. So you're contributing this much money into an interest-bearing account that earns 6% a year. Okay, this 6% is compounded per year. Okay, which means if you're using 6%, you're going to use the $520 per year as your annual investment instead of $10 per week. Okay, that's probably one less pizza per week, which means if you skip one pizza per week, that money saved can be almost $10. Okay, and if you save that money into a saving account at 6% interest rate per year, you can save a lot of money. So now, if you want to save this, keep doing this every year for 15 years, how much you can save. Okay, so based on this problem, what statement describes the question correctly? So this is to look for the future value of your current, the continuing $520 saving per year for 15 years. Okay, so it's to find the equivalent future value of an annuity. Okay, future value of an annuity. And based on this problem, if you use factor method to solve the problem, which formula is correct? So factor method, the formula, you're looking for future value, okay? And given annuities, so this is the formula. And the annuities, because the interest rate 6% is per year, so you cannot use $10 per week as your annuity. You need to use the $520 per year saving as your annuity. So A is 520, and I is 6%, N is 15 years. Okay. And so how much money would you have saved at the end of the 15 years? So you need to calculate the F now. F equals to A times F slash A. I equals to 6%. N is 15. A is 520. And this factor is 23.2760. So the answer is 12103.52. Okay, the last problem. Assume that you are given a cash flow diagram as in below to calculate the equivalent present value of all the cash flows on the timeline. So it's multiple cash flow problems. The first step is to determine how many different cash flows you need to convert to the present time as parts of 0p. Remember what we have done in the class. We always look at how many parts you need to convert for P0, okay, for present worth. So in this cash flow diagram, you have 3 different cash flows. So you need to have 3 parts for calculating the P0. So 1 part, 2, part 3. Okay, so for the first question, how many parts do you have for P0? 3. And what is the value of P0? So P0 is from 3 parts. P0-1 is from the $200, it's negative. And it's a value at the end of the first period. So it's compared to the present value, it's to convert to the future value to present, right? And the P0-2 is from the 400 at the end of the second year. It's still a future value converted to present value. And the last part is P03 is from the 100 at the end of the 6th year. It's still to convert the future value to present value. Okay, And well, in these four answers, among these four answers, they're all positive, but actually it's an outgoing cash flow, so there should be a negative sign in front of it. But since they're all, since they're all the cash flows are negative, so we don't have to differentiate the negative from the positive. So it's fine to just ignore the signal for this problem. But of course, you can include the negative signal, okay? And in the final example or in the test, I am going to include the signal all the time, so you don't get confused, okay? So now let's continue to calculate what is P01, P02, and P03. P01 equals to, if you want, you can include the negative sign, okay? It's 200 times, it's to convert a future value to the present value, so it's to find P/5/F. Interest rate is 20%. Because it's only 1 year from the present time, so it's converted one time, so it's n equals to 1, and this is 166.66. And the P02 is from the 400 P/F still 20%, but it's 2 years from the present time, so it's compounded 2 times, so n is 2. The answer is negative 277.76. P03 is from the 100 at the end of the 6th year, P/F 20%, and it is 6, okay? N is 6. So this is 33.49, okay? So the P0 is the sum of these 3 parts. The total is 477.91, okay? So it's gonna be this one. All right, the last problem is about the effective interest rate. So a credit card company charges a nominal interest rate of 12% compounded monthly. So nominal annual interest rate compounded monthly. So what is the effective annual interest rate? We have a formula, right? So this is the formula you need to use. But to use this formula, you need to determine what is R, what is M, okay? So R is the nominal annual interest rate, which is 12%. M is the number of compounding period per year. So because it's compounded monthly, it's compounded every month. So for a year, it's compounded how many times? Because there are 12 months a year, so it's compounded 12 times. So M is 12. So this question, R is 12%, M is 12.